Hello, all, and welcome. We're going to get started with our next example. This example in asymptotic analysis is going to be how we show that 2 times n to the 5 is, 2 times n to the 5 minus 7 times n cubed is in big omega of n to the 5. And so as we have been doing, we are going to start with our definition. So first, our definition of big omega. There exists an m greater than 0, and there exists an n naught greater than 0, where for all n and for all any n greater than n naught, such that f of n, which will be this side, will be greater than or equal to m times g of n, which will be this right here. This is g of n. Okay, so let's just rewrite this with that information in place. N not greater than 0 for all n, n greater than n naught, 2n to the 5 minus 7n cubed is going to be greater than or equal to m times n to the 5. And so just as we did previously, we're going to go ahead and pull out, pardon me, that n to the 5 and get that factored form again. So we can say n to the 5, 2 minus 7 over n squared is greater than or equal to m times n to the 5. And right away, we can see that this m needs to be equal to at least this situation right here for us to be able to solve this problem effectively, pardon me. So as we've done previously, we're going to try and get this value to hit a 1 if possible. Is there a way for us to hit a 1 with just this one term here of 7 over n squared? So then we'll be able to say that n to the 5 times 2 minus 1 will be strictly greater than or equal to n to the 5, which is greater than or equal to m times n to the 5. So as we start to see that, we can kind of hear what we need to do. We can hear that if we can find a way to get this value, I'm going to change colors. If we can find a way to get this value to be a little bit less than 1, we'll be able to show that this whole term here is greater than or equal to 1, which will allow us to make a new term in the middle where m will be equal to 1. So let's actually just write that down, that we do want to find a way to get m equal to 1. Boy, would that make our life easy. So now, what kind of value do we need for n in order to solve this problem right here? Well, we do know that if we need that to be strictly less than 1, we need n squared to be greater than 7. So then that way we will end up in a position where we can have a fraction there instead of 7 over 7 being that 1. Now, there's absolutely no reason to take the square root of this or anything like that to get a tight lower bound on n, because all we need to do is find an n naught that exists. So if n naught is equal to 7, we'll know that n is greater than n naught, which will mean that n is greater than 7, which will then imply that n squared will be greater than 7. And that's actually good enough for us. So let's go ahead and write this out officially. So we start off with our definition. So by the definition, sorry, my cat is like hitting my screen. By definition, 2n to the 5 minus 7n cubed will be in that, big omega of n to the 5 if there exists an m greater than 0 and there exists an n naught greater than 0 for all n greater than the n naught. 2n to the 5 minus 7n cubed is greater than or equal to m times n to the 5. So here we get to do our step 1 where we actually pick those values. So let's let m equal 1 and n naught equals 7, which implies for all, or I guess we should just say which will implies n is greater than 7. So let's prove, that doesn't spell prove. Let's prove that for all n greater than 7, 2n to the 5 minus 7n cubed is going to be greater than or equal to n to the 5. Okay. So how are we going to go about doing this? Let's let n be some arbitrary value. Oh, I will say that the reason that m disappeared right here is because that m is just the one that's sitting there, because we did say let m equal 1. So we could actually just slot the 1 in there, and now it's gone. Just as a general understanding of what the heck I just did there. So, okay, so let's say, we're going to let n be arbitrary. Let n greater than 7 be arbitrary. And by 1, we can see that n squared is also going to be greater than 7 then. And this implies that 7 over n squared will definitely be less than 1. So we're going to say 7. Let's actually pull all this out and together. N to the 5, we'll say 2n to the 5 minus 7n cubed is equal to, take out that n to the 5, 2 minus, sorry, my cat is driving me crazy, 7 over n squared. And then this is greater than or equal to n to the 5, 2 minus 1. And that's true because of our number 2 there, because of the values we've chosen. So that is true just from the values we've chosen. And then we're able to say that since m equals 1, n to the 5, 2 minus 1 is the same as just saying n to the 5 less than or equal to m times n to the 5, which as we know is just n to the 5 as needed. So we've shown that n to the 5 is indeed less than or equal to n to the 5. And that's all we have to do in order to officially do this proof. So after, we've got maybe one more proof where it won't be too tricky. And then after the next proof, we're going to start getting into a little bit trickier sort of notation and constraint situations. So yeah, so one more example, and then be sure you have a nice strong foundation before you start going through example 6 and beyond. All right, thanks everyone, and I'll see you in the next video. Bye.